tensile forces are developed. So, the question may arise, what the bending moment does to the beam? First, it causes compression on one force and tension to the other side. So, repeat, this bending moment causes the compression on the one face of a beam, and on the other face tension to the other face. It causes the beam to deflect. So, this bending moment creates the deflection on the beam. So, let us be understood the concept of bending stress. The beam bend due to the effect of external loads and take a curved shape that had been visualized in the previous slide. Hence, the stresses produced due to the bending moment is called bending stress. Very simple. Bending stress is defined as the stress which is produced due to the bending moment. In the case of a positive or sagging bending moment, the beam concave upward. This bending results in compressive in the top fibers of the beam, which shorten in length, and tension in the bottom fibers. These stresses are known as bending stresses. I will revise the statement once again on this tabletop. So, if this is the beam, if I will draw in 3 diagram, this is the support, this is the another support on the other side. Now, when the loads which are acting over here, this leads deflection. Also, because of that, this top part are under compression and this bottom fibers are under tension. This leads stresses. That stresses are referred as bending stresses. So, the question may arise, what is pure bending? Let us be understood with this concept. It is important to distinguish between pure bending and non-uniform bending. So, one term that we have to study about the pure bending, the bending which is developed because of purely bending moment only. There is not a single incorporation of shear force. It is understood over here. Pure bending is the deformation of the beam under a constant bending moment. Therefore, pure bending occurs only in a region of a beam where the shear force is 0, because V is equal to dm by dx. Please refer this or understood this words carefully. Let us take a beam, simply supported beam with the 2-point load at the, means all the 3 are the equal region. Means if the L is the length of the beam, then this part is L by 3, this part is L by 3, this part is L by 3. So, if we plot the shear force diagram, so we have to find out first of the support reaction. I think let us plot over here on the tabletop. This is a given beam to us, simply supported beam with the 2-point load W. L by 3 are the distance. I want to plot the shear force diagram. To plot the shear force diagram, I have to first of all find out the reactions. As my beam is under symmetry, then this is W, this is also W. Hence, if we plot the shear force diagram W, that is the reaction itself, support reaction, between these 2 points, no load, horizontal straight line, suddenly change W. There is no load between this span, so 0, 0, 0 throughout, no change at all. Under this load, goes down W to straight W. Negative sign, positive sign. This is my shear force diagram. Why we have taken the simple case? Because please refer the zone over here when there is a zero shear force is there. Now if we plot the bending moment diagram, baseline is there, W into L by 3 is the bending moment developed over here. Here it is a straight line, once again WL by 3, and it is 0, plus sign. So please refer over here. Here the bending moment is constant. Here the shear force is 0. So the stresses developed because of this in this region, in L by 3 region of a beam, are known as pure bending stresses. So my beam is under pure bending in this region. So please refer the figure in this PPT. Refer this region. Zone of pure bending. This zone is referred as under pure bending because the shear force is 0 in this region. So it is to be also called pure bending. So non-uniform bending is a deformation in the practice of shear force, presence of shear force and bending moment changes along the axis of the beam. Means if we take over here in this tabletop, then this portion are non-uniform bending, and this zone is under non-uniform bending because bending in this region and in this region is because of bending moment as well as the shear force. Both has been incorporated. So bending stresses are developed in this region is because of shear force as well as because of bending moment. While in the central L by 3 region, this developed because of pure and bending moment only, because the shear force in this region is 0. Now, how to calculate the bending stress? It is utmost necessary for us to know how to calculate the bending stress. So, we should know on which this bending stress depends. First, the bending stress depends on the beam cross section. So we need some particular properties of the section. So we should know how big and what will be the shape. Is the section we are using as a beam? Means if a section is of a rectangular section, maybe a square section, maybe of L section, maybe of I section, maybe of hollow rectangular section, maybe of hollow circular section, depending upon the type of the shape, my bending stress changes. So we have to take the incorporating of this type of cross section also. So refer the various cases of pure banding. Here refer a woman have weightlifting over here. She is standing, see the posture with the two hand. So what happens, whatever the load over here, same will be hanging by the hand over here, and whatever the load will be over here will be hanging over here. So the central region is under pure bending. Please visualize carefully with this example. So pure bending means the prismatic members subjected to equal and opposite couples acting in the same longitudinal plane. So now today we learnt up till now the cases, the relationship between shear force, bending moment and the loading. So how it will behave under the various kinds of loading. And we have also today introduced the concept of bending stress. We have also understood what is the meaning of pure bending. So in the next session we are going to derive the equation of pure bending. We will understood how the cross section affects for the bending stress. Thank you.